All right, welcome back to Unit 8. We are going to start the trigonometry unit. And we're going to start with a review from what we did in pre-calc 11. And this might be hopefully not too difficult for you, but it's mostly review with a couple of things that's new. Okay, so let's take a look. It says when a ray rotates counterclockwise about the origin from the positive x-axis, it forms a positive angle in standard position. It forms a negative angle if it rotates clockwise. Okay, so here is my here are my axes, x and y axis. Okay, so if we start from the positive x-axis and let's say we rotate counterclockwise, here's the angle in standard position, and this is actually positive. But if you rotate the other way, right, if you rotate this direction, clockwise, then this angle is still in standard position, but then it's now negative, okay? Okay, so that's the first piece. Second part says, reference angle is the angle between the x-axis and the terminal arm. So recall this is where the angle terminates, so this is what we call the terminal arm. So here is the angle, theta, but reference angle is the angle between the terminal arm and the x-axis. Okay, and it's also less than 90 degrees. So you can see this is definitely less than 90 degrees. Okay, so in this case, here is the terminal arm, here's the x-axis. So here is the reference angle, and you can see that is also less than 90 degrees. Okay, so that's what we did last time, or sorry, not last time, in pre-calc 11. Now, of course, the angle could be in other quadrants. It could be here, and let's say here's my angle in standard position. Then this would be the reference angle, right? Because again, that's between the terminal arm and the x-axis, and it's also less than 90 degrees. Okay, we also talk about the all students take calculus rule, I think. Okay, so I'm going to quickly review that. That's AS also take calculus. So this means that all the ratios, sine, cosine, and tangent in quadrant 1 would be positive. In quadrant 2, S stands for sine. Only sine is positive. In that case, that means cosine and tangent would be negative. In the third quadrant, only tangent is positive, so sine and cosine will be negative in the third quadrant. And in the fourth quadrant, cosine is positive. So that means sine and tangent will be negative. Okay, so again, A stands for everything, all. All the trig ratios will be positive, only sine is positive, only tangent is positive, and only cosine is positive. So based on that, we can use the reference angle and the concept of the CAS rule, or all student take calculus, to do the following question here. It says, determine the values of x between 0 to 360 degrees that satisfy each equation. So here it says sine of x equals to 45 degrees. Obviously, if x is 45, then it's going to work. Okay. Now, there's another one. Because we can look for the reference angle. Now, sine, this 45 degrees is in quadrant 1. Okay, so we're looking in quadrant 1, in which case all the values or all the ratios is positive. Now, sine in the second quadrant is also positive. So as long as we can find an angle that has a reference angle of 45, and it's in the second quadrant, then the ratio of that for the sine will be also the same as sine 45. So what that means is if we look for an angle in the second quadrant that has a reference angle of 45 degrees, which means this angle right here, okay, that would also be equal to sine 45. Okay, so to find out theta, all you need to do is you go 180 minus 45, which is 135. Okay, so if x is 135 degrees, sine of 135 would actually equal to sine 45. Okay, similarly, for part B, obviously 45 would always work because that's just the same as sine 45. But again, we're looking at cosine 45. Again, 45 degrees is in the first quadrant. So cosine is positive, but cosine is also positive in the fourth quadrant. So again, that means if I can find an angle in the fourth quadrant that has a reference angle of 45, if the reference angle is 45, then cosine of that angle is going to be the same as cosine 45. And in this case, angle theta, I'm just going to call x, okay? X is just simply going to be 360 minus 345, which is going to be 315. Okay? Finally, part C, again, same idea. Tangent 45 is positive in quadrant 1. Tangent is also positive in the third quadrant. So x would equal to 45. And the angle that has a reference angle of 45 in the third quadrant, is this one right here. And to find that, you go 180 plus 45, which is 225 degrees. Okay. Notice cosine 225 is not going to be the same as cosine 45. It's going to be the negative of cosine 45 because in the third quadrant, cosine will be negative. Okay, and so on. Okay, so again, we did this in pre-calc 11. I don't know if you remember, but that's okay. That's why we do the review. Okay, we're actually reviewing quite a bit today. Okay, coterminal angles. You might have heard in pre-calc 11. I can't remember, but coterminal angles are simply the angles that share the same terminal arm. Okay, so if we look at the angle, let's say 45 degrees, okay, coterminal angle would be any angle that has the same terminal arm. Okay, so this angle would be the coterminal angle to 45 degrees. Okay, and to find that, you simply take 45 and recall one full circle, one full rotation is 360 degrees. So to find this angle, you simply go 45 minus 360. So negative 315 degrees. That would be the coterminal angle to 45 degrees. And of course, we can go the same. So we can go this direction, go backwards, or we could do it this way, right? We can actually do more than one single rotation. In this case, you take the 45 and you add to the 360, right? Because you're going one more full rotation. So you simply add those two numbers, you get 405 degrees. So both negative 315 and 405 are coterminal angles to 45 degrees. And of course, you can keep going, right? You can add another 360 or take away another 360 to get to more coterminal angles. Okay, so here's the first example. Let's see. It says determine the measures of all the angles in standard position between negative 600 degrees and 600 degrees that are coterminal with the angle of 200 degrees in standard position, and sketch all the angles. Okay, so part A, 200 degrees is right here. Okay, we want to find coterminal angles. Again, all you needed to do is to simply add one more full rotation. Okay, so you go 200 plus 360, which is going to be 560 degrees. Okay, so that's a coterminal angle. Or you can go backwards. So this is, 200 is not there, 200 is here. So this is 200. But if we go backwards like that, so we end up with the same terminal arm. You go 200 minus 360. This is negative 160 degrees. So that's another coterminal angle. And I believe we can find one more because we can do it one more time. Oh, wrong direction. So again, we stop over there, but then we can go like that twice, right? So you go 200 minus 2 times 360. You do it twice. This is negative 520, which is still within our range. So that's fine. So you actually end up with 3 coterminal angles. And you can keep going with 560 by adding 360, but you'll see that it's going to be beyond 600. Same thing, you can subtract another 360 from negative 520, but that's going to be less than negative 600. So we're going to stop right there. Okay, so we have 3 coterminal angles. Part B says, write an expression for the measures of all the angles that are coterminal with an angle of 200 degrees in standard position. So notice what we did was we added 360 or we subtracted 360. So we can actually come up with an expression. Coterminal angles is simply going to be 200, so that's where we start with, plus 360 times n, where n is simply the element of integers. Okay, so those would be coterminal angles to 200 degrees. Okay, so that means 200 plus 360 times 1 times 2 times negative 1, negative 2, and so on. Okay, so that's the first example. It's not too bad. All you needed to do really is just to add 360 and subtract 360 to find coterminal angles. And we did some review of the reference angles. Okay, unit circle, this is something new. Unit circle is actually quite easy to define. It's simply a circle with radius 1. Okay, so basically like this. Okay, not a very good circle. That's okay. Okay, 1, 1, -1, -1. It's not really better. Okay, anyways, that's good enough. The right hand side was pretty good actually. All right, I give up. Anyways, so this is a unit circle because the radius is 1, so the coordinates of these 4 points would be 1, 0, 0, 1, -1, 0, 0, -1. So this is the unit circle. Okay, and we're gonna use this unit circle to do a lot of questions. Okay, so let's quickly recall from what we did in pre-calc 11. It says when the terminal point P x, y of an angle theta in standard position lies on a circle with radius r, the coordinates of P are x equals to r cosine theta and y equals to r sine theta. Again, we did this in pre-calc 11. I'll show you quickly. I'm not going to spend too much time on it. Let's say here's the circle and radius r, and this point is x, y. Here's angle theta. Okay, so that means this is x, and that's y. So we can actually, so then we can actually say cosine theta is equal to adjacent over hypotenuse, so x over r. You can solve for x by multiplying both sides by r, so you get r cosine theta equals to x. That's how you get that. Similarly for y, okay, so y is equal to r sine theta. Okay. However, for the unit circle, r is equal to 1, right? The radius is 1. And therefore, the coordinates of P would be x equals to cosine theta. Again, because radius is 1, so r doesn't really matter anymore. It's just going to be 1. So 1 cosine theta, or just cosine theta. And y is going to be sine theta. And therefore, y over x is going to be sine theta over cosine theta. And why is this important? Because y over x is simply tangent, right? Because that's opposite over adjacent. That's the opposite side, that's y, and x is the adjacent side. So y over x is actually equal to tangent theta, which is actually equal to sine theta over cosine theta. Okay, so that's important. So the key is this. The key takeaway is that whenever you think about cosine, you think about x value. When you talk about sine, you think about y values. Okay, so that's the key takeaway here. Okay, so now that's what we did last year in pre-calc 11. Okay, just review. This is something new. We're going to look at the reciprocal trig ratios. It says there are 3 other trig ratios that are related to the primary trig ratio. So again, the primary trig ratios are the sine, cosine, and tangent. And we are going to be looking at the reciprocal of these 3 ratios. Okay, so suppose point P, x, y is the point where terminal arm of angle theta intersects the unit circle. The reciprocal of cosine theta is, well, of course, 1 over cos. And we have a name for this. This is called a secant theta. Okay, SEC, secant theta. Okay, so, and of course, if cosine theta is equal to x, that means secant theta is 1 over x because, right? Oh, what happened there? It's too much. Okay, so cosine theta, recall, is equal to x. Therefore, 1 over cosine theta, which is secant x, or secant theta is 1 over x. Right? That's how we get this. Secant theta is 1 over x. So similarly, for sine theta, the reciprocal is 1 over sine theta. Again, we have a special name for this. This is called cosecant theta, CSC. Okay, this one is secant, and this one is cosecant. But we write it CSC for short. So this is cosecant theta is equal to 1 over y. Okay, now we have a reciprocal for tangent, and of course this is 1 over tangent theta, and this is what we call the cotangent theta. And cotangent. Okay, COT, cotangent theta, and cotangent theta is equal to x over y because remember tangent theta was y over x. So cotangent is just the reciprocal Therefore, x over y becomes y over x. Okay, just the reciprocal. Okay, so these three are new. Okay, but they're not that difficult. They're just the reciprocals. Okay, nothing tricky here. Okay, special triangles, that's important as well. So special triangles are important. Unit circle is important. Those three diagrams you need to remember. Okay, special triangles. Recall we have two of them. One of them is the 60 degrees, 30 degrees, 30, 60, 90 degree triangle, okay? And the ratio for the sides, recall it was 1 to root 3, okay? 1 is opposite from the smallest, again, because that's the shortest side, which is the opposite from the smallest angle. The biggest angle is 90 degrees, so the opposite side has to be longest, right? That's a 2. 60 degrees in the middle, so the length is somewhere in the middle between 1 and 2. Okay, we're somewhere between 1 and 2, not middle. Okay, so root 3. So that's one of the special triangles. The other one is the 45, 45, 90. So 45, 45, and this is isosceles. So these two sides will be 1 each by using Pythagorean theorem. That's root 2. Okay, so 1, 1, root 2. Okay, so these are the special triangles. Okay, these are the special triangles. And so these two you need to remember. And again, the unit circle you need to remember. Okay, unit circle is easy to remember. Okay, 1, 0, 0, 1, negative 1, 0, 0, negative 1. So these three things, make sure you have them memorized. Okay, because we're going to look at exact values. Okay, so example 2 is says determine the exact values of 6 trig ratios for negative 750 degrees. So the very first step that we need to do is to find the reference angle of negative 750. Okay, that is always, well, I shouldn't say always, but most of cases, always the first thing you need to do is to find the reference angle. So negative 750. What we can do is because negative 750 is kind of difficult to think about, what we want to do is to find the coterminal angle. Okay, and that's between maybe 0 to 360, because then that's easy to do, right? And again, to find coterminal angle of negative 750, all you needed to do was, I mean, you could add or subtract 360, but I mean, clearly you don't want to subtract more, right? So you want to add 360 to make it positive. And I believe if you add 360 3 times, you actually end up with some positive value. If you do it twice, it's negative 30. You know what? I'm just going to do it, you know what, 3 times. I like to keep it positive. I think this is going to be 330, but yes, it's 330. Okay, so this is 330 degrees. That means this negative 750 is equivalent to this angle right here. I shouldn't say equivalent, but a lot of the properties will be equivalent because they share the same terminal arm. Okay, so basically I'm looking at this angle. Okay, now if this is 360, what is the reference angle? Well, if this is 360, I know this then would be 30, right? Because that's one full rotation, it's 360. So if that's 330, I have 30 left to go. So that's 30 degrees right there. And this, look at that, that's a special triangle, right? This is 30, this is 60. Then we can fill in the ratio for the sides. It's 1 to root 3. So the opposite side of 30 is 1. Hypotenuse is 2. And this is root 3. So now we can actually write or figure out all these ratios. Sine negative 750, cosine negative 750, tangent negative 750. And the reciprocal for sine, again, is cosecant. So cosecant negative 750, secant, that's the reciprocal for cosine, secant negative 750, and cotangent negative 750. Okay, so one at a time. So sine, if we're looking at negative 750, again, we look at its reference angle, which is 30 degrees. So we look from this angle, sine is opposite over hypotenuse, which is going to be 1 over 2. However, remember, we need to consider whether sine is positive or negative in the fourth quadrant. In the fourth quadrant, only cosine is positive, therefore the answer would be negative 1/2. Okay, for cosine, the ratio is adjacent over hypotenuse, so root 3 over 2. And in this case, because we're in the fourth quadrant, so cosine is positive. Finally, tangent is opposite over adjacent, so that's 1 over root 3. And we're in the fourth quadrant, Tangent is negative, so the answer is negative. Okay? And for the reciprocals, you simply flip the fraction. Okay, so this was negative 1 out of 2. It's going to be negative 2 out of 1, which is just negative 2. This was root 3 over 2, so it's now going to be 2 over 3. This was negative 1 over root 3, so now if you flip it, it's going to be negative root 3 over 1, which is just negative root 3. Okay, so that's the second example. Hopefully that's not too bad for you. Okay, moving on. This is a long lesson, okay? Moving on to example number 3. Let's see. It says the point 5 comma negative 2. 5 comma negative 2 is somewhere here, which means the x value is 5, so that's 5. The y value is negative 2, so the length right there is 2, and that's 90 degrees right there. This is the terminal point of angle theta in standard position. So here is angle theta, and this is the reference angle. Determine the exact values of the 6 trig ratios for angle theta. So now we are looking for sine theta, cosine theta. I shouldn't. Okay, I'll leave some room here. Sine theta, cosine theta, tangent theta, and the reciprocal of these, so cosecant. Oops, that's not cosecant. Cosecant theta, secant theta, and cotangent theta. Okay. Now, sine, again, is opposite over hypotenuse. We don't have hypotenuse yet, so we need to find it. So to find hypotenuse, let me call this the radius. R squared is equal to 5 squared plus 2 squared. Hopefully you know how to solve for R. This is going to be root 29. Okay, so sine theta is simply going to be opposite over hypotenuse, so that's going to be 2 over root 29. But then again, you need to consider the cast rule. Okay, CST, ASTC, whatever you want to call it, add sugar to coffee, whatever. Sine in the fourth quadrant, again, you can see our angle is in the fourth quadrant. The answer is going to be negative. The ratio is going to be negative. Cosine is adjacent over hypotenuse. In the fourth quadrant, cosine is positive. Tangent is opposite over adjacent. But in the fourth quadrant, tangent is negative. Again, for the reciprocal, cosecant is simply going to be negative root 29 over 2. Secant is going to be root 29 over 5. Cotangent is going to be negative 5 over 2. Okay, so that's the example 3. I want you to try the next question. Okay, so I'll pause this and then hopefully you can do this on your own. Okay, good luck. Okay, so here's the answer. Okay, so hopefully this is what you got. Negative 3 and 4 is in the third quadrant, so I drew my triangle, and then I have the ASTC rule, found the radius, and just apply the rules, and then the side length, and this is what you should get. All right, hopefully that's okay for you. We're going to move on to example number 4. Okay, so here it says, suppose cosecant theta is equal to 4. Part A says determine the exact values for other trig ratios for theta between 0 and 180. Okay, and part B, to the nearest degree, determine the positive value of theta in the domain from negative 360 to positive 360. Okay, so one question at a time. Okay, so suppose cosecant theta is equal to 4. Recall cosecant is equal to is the reciprocal of sine. So if cosecant theta is equal to 4, that's the same thing as 1 over sine theta is equal to 4. And we can actually rearrange this and then say that sine theta then equals to 1 over 4. Okay, you can rearrange it and that's what you get. Okay, you can cross multiply and solve for sine theta, or just do some manipulation of the algebra. I mean, cross multiplication really is just also the manipulation of the algebra. Okay, anyways, so sine theta is 1/4. Okay, so now we can find the ratios of other trig ratios. Okay, so, well, I guess first of all, let's draw out the diagram, I guess. It says for 0 to 180. Now, here is a sine theta is 1/4. So sine is positive. So we actually have 2 cases. Okay, we have 2 cases. So I'm going to write this out. We have 2 cases. case 1, and case 2. Okay, case 1 is where the angle is in the first quadrant, because we don't know, right? It says between 0 and 180, so it could be either or. Since sine is positive, so really there are two possibilities. So if it was in quadrant 1, then it's simply like this. It's just going to be like this: 1, 4. We can find the third side using Pythagorean theorem. I'm going to skip that step. It's going to be root 15. If it's case 2, same thing, but in quadrant 2. Okay. Case 2. It's going to be here, and it's going to be same thing. Opposite is 1, hypotenuse is 4, the adjacent side is root 15. Okay, and here's angle theta. In this case, here is angle theta. Okay, now we can actually then write down sine theta. We actually already did, so I'm not going to write sine theta. Oh, you know what? I should. So sine theta, cosine theta, tangent theta. Sine was a quarter. Cosine, in the first quadrant, everything is positive. So this is going to be root 15 over 4, adjacent over hypotenuse, opposite over adjacent. Okay, and then we would have the cosecant, which is just 4. That's the question, right? So we know that. We have the secant, which is going to be 4 over root 15. Finally, cotangent, that is going to be root 15 over 1, which is simply root 15. Okay, so that's case 1. You can find the 6 trig ratios right there. And then if we do the same thing for case 2, really it's going to be almost exactly the same thing, except some of them would be negative instead. Okay, because we're in a different quadrant, so the ratio actually will remain the same, but the signs are just going to be negative. Okay, and the ones that are going to be negative will be the non-sine and cosecant ones. So these two will remain the same, but the rest will be negative of what it was if it was in quadrant 1, right? So then now it's going to be negative 4 out of root 15, and this is simply going to be negative root 15. Okay, it's just the negative of what it was in quadrant 1. Okay, so that's part A. Part B says, to the nearest degree, determine the possible values of theta in the domain from negative 360 to positive 360. So again, this breaks into two different cases. Case 1. If it was in the first quadrant, okay, then we can simply take the first, the sine ratio. Sine theta is equal to a quarter. You can put this into calculator. So we simply take the inverse sine of a quarter, which is going to be, I don't remember. Well, actually, it's not, I don't remember, I don't know. Inverse sine of 0.25. This is going to be, I'm going to round to the nearest tenth. Oh, it says nearest degree, so 14.47. So I guess 14 degrees. Okay, so that's case 1. Now, the domain goes from negative 360 to positive 360. So that means we need to find other answers that would be the same, or would be the coterminal angles, because if it's coterminal angle, they end up with the same terminal arm. So this is my first answer. I'm going to call this theta 1. I can find a second answer by simply adding 360. Now notice, if you add 360 to 14, it's going to go beyond our domain right here, right? It's going to be more than 360. So instead, I am going to subtract 360. So this will give me 346 degrees. So that's my second answer. Okay, that's my second answer. Okay, and again, I can keep subtracting 360, but I think it's clear if you subtract another 360, it's going to be way less than negative 360. Okay, so that's my first two answers. And now I can look at my case 2, because it does not have to be in the first quadrant. It could be in the second quadrant. In that case, you still do this, okay? You still do this. I know that because I mean, sine in the second quadrant is still positive. The reality is you should always find the reference angle first, and to find the reference angle, you always take the trig ratio of the positive ratio. Okay, it doesn't matter which one you choose. Okay, you can choose the cosine one, but whenever you're looking for reference angle, you always take the inverse trig ratio of the absolute value of the the ratios. Okay, so if it was negative a quarter, you still take the inverse sine of the quarter. Okay, it doesn't matter if it's positive or negative. To find the reference angle, you always use the positive. So the reference angle is going to be 14. Okay, but our angle is not going to be 14 because we are now in the second quadrant. So we know this is going to be 14. So this is our third angle. And to find that, we take 180 and we minus 14. This is going to be 166 degrees. So that's my third answer. And again, I can find coterminal angles by either adding 360 or subtract 360. I think it's clear that we will need to subtract. If you add another 360, it's going to be too much. This is negative 194. So that is your fourth answer. And you only have these 4 as your answers. Okay, you have 4 different possibilities. Okay, so 2 different cases. So you got to solve them separately. Okay. Okay, so now you should try the next example or next practice questions, and good luck, home. Okay, sorry for the interruption. Yeah, good luck trying this question, and then I'll show you the answer in a bit, okay? All right, so for this one, secant theta is 3.5. So first of all, I'm going to change 3.5 to a fraction, which is 7 over 2. And that means cosine theta then would equal to 2 out of 7. Okay, and part A says we're looking for the exact values of the other trig ratios for the theta between 0 and 180. Now, cosine is positive in quadrant 1 and 4. Now, if we're only looking at the range or the domain from 0 to 180, that means we only have one case, because the other case should be in quadrant 4, but that's outside of our domain, so we don't need to consider that. So for part A, we're only looking at this triangle. We only have one case, okay? So 2 and 7. Hopefully you got that. We don't actually have 2 cases because the other case would be in quadrant 4, but that's outside of our domain here. So adjacent over hypotenuse is 2 and 7 there. We can find this. This will be root 45. Again, using Pythagorean theorem. I will skip that part. Hopefully you understand how to get that. Now from here, all we need to do is to find out sine theta, cosine theta, and so on. Sine theta, cosine theta, tangent theta. What else? Cosecant, secant, whoa, and cotangent. Okay, so for sine, it's opposite of hypotenuse, so root 45 over 7. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is just the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So those are your 6 trig ratios. So that's part A. Part B, however, it says to the nearest degree, determine the possible value of theta in the domain from negative 360 to positive 360. This is the one that we will actually consider 2 different cases, okay? Because it could be quadrant 1 or quadrant 4, because cosine is positive in both quadrants, okay? So let's look at case 1, where it's in quadrant 1. Here's theta. Okay, so we can find, it says, I'm going to use sine in this case, okay? I'm going to use sine in this case. So sine theta is equal to root 45 over 7. Therefore, reference angle is simply going to be the inverse sine of root 45 over 7. The reference angle is going to be inverse sine of root 45 divided by 7. This is going to be 70 nearest degree, I guess, so 73 degrees. And therefore, theta 1 is simply 73 degrees, because that's just that, right? The reference angle is the angle itself. Theta 2, we need to take 360 away from 73. This is going to be negative 287 degrees. Okay, so that's your theta 2. That's your second answer. First answer. Notice I didn't add 360 because if I add 360, it's going to be more than 360, and I stopped subtracting 360 from here because then otherwise it's going to be less than negative 360. Case 2. So now we are going to be in quadrant 4, and here is the angle theta, and this is the reference angle. Reference angle is going to be the same, okay? So the reference angle is still going to be 73 degrees. However, theta 3 is not 73, it's going to be 360 minus 73, right? Because the reference is 73. So this is going to be positive 287 degrees. And to find theta 4, simply take 360 away from 287. This is going to be negative 73 degrees. So here's my theta 3, and there is my theta 4. Okay, so that's it for this lesson. Again, it's really a bit of review and a bit of new stuff from this year. So let me tell you this, okay? This lesson is very, very important. If you don't get this, next lesson you will have no idea what's going on, okay? Because next lesson we're going to introduce a new unit. Notice how everything we're dealing with right now is in degrees. We're going to use a different unit next lesson, okay? Just like when we measure length, we could use centimeter or we can use inches, right? So it's two different systems, and that's what we're going to be doing next lesson. Right now we're using degrees, but we are not using degrees next time, and that could cause some confusion, okay? So make sure you understand this well, because starting next lesson, we're going to move on to a different unit. So you'll be basically doing the same thing, but with a different unit, but you'll actually be quite a bit more challenging, okay? So just give you a heads up. Make sure you understand this unit, okay, or this lesson, do the questions, and let me know if you need some help, okay? So good luck. See you later.